Good morning, students. I am Dr. M.Maria Julie, Assistant Professor, PG and Research, Department of Physics, St.Joseph College of Arts and Science, Autonomous, Cuddalore. Now, I am going to talk about loss of energy due to sharing of charges. So, loss of energy due to sharing of charges. During the sharing of charges between the different bodies, no net loss of charge takes place. During this process, some energy is disappeared in the form of heat. But some amount of energy is scattered in sharing between these charges. Now, if we want to calculate the total loss of energy during the process, then we have to take two capacitors having capacity C1 and C2. These also have their distinct potentials, say V1 and V2. As we have discussed above that the charge always flows from the capacitor having higher potential to the capacitor having less potential. So their common potential is given by the equations below. So V is equal to C1 V1 plus C2 V2 by C1 plus C2. So this is equation number 1. Total energy of the system will be E1 is equal to half C1 V1 square plus half C2 V2 square. So this is equation number 2. So E2 is equal to half C1 plus C2 into V2. So E2 is equal to half C1 plus C2 into C1 V1 plus C2 V2 by C1 plus C2 the whole square. Here we have using equation number 1. E2 is equal to half into C1 plus C2 into C1 V1 plus C2 V2 the whole square by C1 plus C2 the whole square. E2 is equal to C1 V1 plus C2 V2 the whole square by 2 into C1 plus C2. So this is equation number 3. So subtracting equation number 2 and equation number 3, we get E1 minus E2 equal to half C1 V1 square plus half C2 V2 square minus C1 V1 plus C2 V2 the whole square by 2 into C1 plus C2. So E1 minus E2 is equal to C1 V1 square into C1 plus C2 plus C2 V2 square into C1 plus C2 minus C1 V1 plus C2 V2 the whole square by 2 into C1 plus C2. So E1 minus E2 is equal to C1 square V1 square plus C1 C2 V1 square plus C1 C2 V2 the whole square plus C2 the whole squared V2 the whole squared minus C1 squared V1 squared plus C2 squared V2 squared plus 2 into C1 C2 V1 V2 by 2 into C1 plus C2. E1 minus E2 is equal to C1 squared V1 squared plus C1 C2 V1 squared plus C1 C2 V2 squared plus C2 squared V2 squared minus C1 squared V1 squared minus C2 squared V2 squared minus 2 C1 C2 V1 V2 by C1 plus C2. So here we take C1 C2 in common, C1 C2 into V1 minus V2 the whole squared by 2 into C1 plus C2. So the above equation shows that E1 minus E2 is greater than 0 or E1 is greater than E2 or E2 is less than E1. So in the derived formula, the capacitance cannot be negative individually. Also, the value of V1 minus V2 the whole square will be non-negative as it is a square value. This implies that the final value will be positive. Thus, initial energy was greater than final energy. Also, for V1 is equal to V2. The difference in energy will be 0. This means that no loss of energy takes place as there is no potential difference initially. There will be no flow of current. Thank you.